Okay, we're gonna take a shortcut here. I've got a couple of videos on the calculating percent grade and slope ratios. Those are two things, two ways of measuring the inclination, lay of land. You know, when you're putting in a pipe, the gravity flow, it makes a difference and things like that. So we went through the video, looked at the profile, but it was a little bit confusing, and I just felt like we don't have to do all this. So I'm looking at this. There's two circles I've got drawn here, and they represent the two things I just talked about. The slope ratio, which is laid out right here, and as you can see, the arrangement of these are a little bit different. The formula for slope is the horizontal divided by the vertical. That's all that is. That's it. Now, when we get over here to percent grade, the formula is the invert for percent grade. That equals the vertical divided by the horizontal. Okay. No matter what we do, it's all based on this, on these two things. We're either going to be looking for a slope, or we're going to be wanting a percent grade. If you recall in that video, we talked about slope is usually used like on each side of the highway when you have a really, let's call it high elevation and slope. The percent grade is used when you're putting in things like stormwater piping, and you in this gravity flow, so you may want it to be like sewer line coming out of your house. You know, that's probably 1% grade. 1% fall over 100 feet would be 1 foot. So we'll get into that as we go along. But right now, you need to pause this video. You need to draw these two circles just like I have them, and along with their little bitty formulas there. Because as you see, slope equals horizontal divided by vertical, and that's this guy up here, horizontal divided by vertical. And percent grade equals the vertical. Notice it changed. Now vertical is up here, divided by the horizontal, which is sitting over here. Vertical divided by horizontal equals the percent. So up here, the horizontal divided by the vertical equals the ratio for the slope. So everything we do is, for the most part, going to be based on one of these two circles. Depends on what we're looking for. So I have also a set of which I will pass on to you guys. You can see here. We'll look at the first one. I think I can go back and forth. Yeah. So this first, I'm not to the first one. There's 20 practice questions here, and I will get them to you as soon as we get through with this video, which is going to be rather lengthy. So the first one, if you can read it, it says that a 2-to-1 slope has a vertical dimension of 4 feet. What is the horizontal distance? Let's go back. I'm not going to keep switching. I'm going to read them and we'll go back and forth afraid I'll lose that. So let's go back to the circles. Now, the first question was, it's a 2-to-1 slope, so it's a slope. So we're concerned with this guy, with this circle right here. So it says it has a vertical dimension of 4 feet. So the vertical dimension, I'm going to put this in here, is 4 feet. All right. Also, it goes on to say, what is the horizontal distance? Well, here is the question mark. It's a 2-to-1 slope. That's the ratio. Goes here. And it has a vertical dimension of 4 feet, which we put right here. And then it asks what the horizontal distance is. What does this tell you to do to find the horizontal distance? We know 4 and we know 2. So 2 times the 2-to-1 slope, you just disregard the colons in there. We know the ratio is 2-to-1. We know the vertical is 4 feet. We need the horizontal, so you multiply the 2 times the vertical, the ratio times the vertical, and that gives you a horizontal of 8. Okay? Now I'll be jotting these things down as we go. The second one says the vertical dimension on a 1.5-to-1 slope is 12. So now we have a 1.5-to-1, and you can write that down like decimal 1.5 to 1. And what is it asking? It says the vertical dimension on a 1.5-to-1 slope is 12. So our vertical is 12. So we're going to change that 4 to a 12. Because it said the vertical. What does this tell us to do? To take that 1.5-to-1 slope, disregard the 1, and take 1.5, multiply it times 12. What does that give you? I will do it. Times 12 equals 18. So that the horizontal distance is 18 feet. Now, the third one, determine the vertical distance for a 2-to-1 slope that has a horizontal distance of 4. That's the third one. So we're given a horizontal distance of 4 right here. So now they change this to 4. In a minute I'm going to quit going through this when I feel like you got it down. So the horizontal distance is 4 feet. Let me get that right. 4 feet. And the so determine the vertical distance on a 2-to-1 slope that has a horizontal distance of 4. So we take the horizontal distance of 4 and we divide it by the ratio because that's all that's left. It's asking us what's the vertical distance. So this is what we don't know. We know this is 1.5 and we know this is 4. What does it tell us to do? To take that horizontal distance of 4 divided by that slope ratio. So let's see what that is. horizontal distance of 4, and we divide that by 1.5, and that gives us, that's not right, 4, horizontal distance of 4, 4 feet. Oh, I'm sorry, no one. It's a 2-to-1 slope. So we would take the. This was on the last one. We're on the. On my count, the third one, determine the vertical distance of a 2-to-1 slope that has a horizontal distance of 4. Horizontal 4, 2-to-1. So we'll change this to 2. And I promise I'm gonna kind of get you to following me on your own. That's 2, and what does it tell us to do? Divide the 4 by 2, and that would give us a vertical of 2 feet. So these slopes, remember, we were going to be looking at prisms. We got a horizontal of 4, we got a slope ratio right here of 2-to-1. So this tells us to take that horizontal distance of 4 and divide it by 2, and that would give us the vertical distance right here of 2 feet. So that's all there is to it. Now, I'm going to get the circles out of the way. I may flash them back and forth, and I'm going to put these actual problems down here so we can see them. And hopefully this is going to work out with all this changing around. It usually gives me fits before I get it right. It's hard to tell which way to move these things sometimes. Okay, so we got number 4 out of the way. Number 3 out of the way. That was determine the vertical distance of a 2-to-1 slope that has a horizontal distance of 4 feet. So, using the circles, we took that horizontal distance of 4 and divided it by the 2-to-1 slope, and it gave us a vertical distance of 2. So that if the vertical, I'm on fault 3 here. Determine the vertical distance of a 2-to-1 slope that has a horizontal distance of 4. So let's try this. Divide and then multiply. Can you see that? So on this we have a vertical distance of 2. That goes over here. This is where your vertical goes. So we have 2 over here. And we have a no. Determine the vertical distance for a 2-to-1 slope. The slope goes over here, 2. That has a horizontal distance of 4. So it goes up here. 4 divided by 2 is 2. There. That's how we got it. And I showed it to you the last time. Horizontal distance of 4. 2-to-1 equals vertical of 2. As it says, 4 divided by 2 is 2. In this case, over here, this vertical is what we didn't know. So determine, and it was asked to determine the vertical distance. So I'm going to try not to have to draw so much. Let's go down to this number 4. Now this is a 1.5 to 1 slope. It has a horizontal distance of 12. So horizontal equals 12. And a vertical dimension of what? So it's a 1.5. The slope equals 1.5. And it says, what is the vertical? Well, if the slope is 1.5, when we get up here, we know the slope is 1.5, and it goes right here, and we know that the horizontal distance, I'm on the wrong one, horizontal distance is 12, has vertical, and the slope is 1.5 to 1. So if we take the 1.5, let me go ahead and draw this. Maybe I can quit in a minute. So here's our little circle with the dividing signs, and then right down here you got a multiplying sign. So let's put the dimensions in. First of all, the slope goes over here, and that's 1.5. Okay. And the horizontal distance is 12. That goes here. And what is it? Just says off, and a vertical dimension of what? Of what? Well, we don't know the vertical again. So what does it tell us to do? 12 divided by the slope of 1.5. So 12 divided by 1.5 equals 8. So the vertical equals 8. And all of this is assumed to be feet, by the way. So there's a couple of them we've done right there. And just to go back, just to remind you, I'm just putting in the things I know right here, and the things I don't know we're going to calculate by using this circle. I'll continue to use this until I feel like you're getting comfortable with it. And I hope you did draw your circle, even if you have to go through 10 sheets. As long as you get this. And this takes all of the, what am I going to do? Because you've got a quiz coming up that's going to give you 2 knowns and 1 unknown, and you're going to have to find it. Let's look at number 5. So I'm going to draw a circle one more time, maybe more than that. And then we got this leg. Now, looking at this, we're talking about a slope, so we got a slope going on here. So it says if the vertical distance on a 1.5 to 1 slope is 2, well, that gives us this, because this is where the vertical goes. So we know that vertical distance is 2. Okay, if the vertical distance on a 1.5 to 1, so that's 1.5 over here on the slope, 1.5 to 1. Then the horizontal distance is, what do we have to do? 1.5 times 2, 3, of course. So it's going to be 3. 1.5 times 2 is 3. So to find the horizontal, you multiply the slope times the vertical, and that gives you the horizontal. That was what we didn't know. We were given this and this. Okay. Right here, determine the vertical dimension for a 1.5 to 1 slope at a horizontal distance of 9 feet. So here we go again. Got a little more room down here. Another dividing, I'm multiplying, and horizontal goes up here, slope goes over here, vertical goes over here. That's always the case. So determine the vertical dimension. That's the one we don't know. Determine the vertical dimension for a 1.5 to 1 slope, 1.5. And we're given the horizontal distance of 9 feet. That's up here. So what does this tell us to do? We don't know the vertical. So we take the horizontal and we divide it by 1.5. 9 for the horizontal divided by 1.5. That equals 6. Then the horizontal distance equals 6. This down here equals 6. Okay. I'm on the right. I'm on this one. Determine the vertical dimension for a 1.5 to 1. Has a horizontal distance of 9. Then it's 6, because 9 divided by 1.5 is 6. And here we go on number 7. Let me go ahead and draw a picture. That seems to be working out for me anyway. So I'll get this done, and then we have a line. We have a division sign here, a division sign here, and going down we have the multiplying sign. So what do we have? We have a 1.5 to 1 slope, so it goes over here. 1.5 goes over here. We're looking for the horizontal. We don't know what that is. All right, but it has a vertical dimension of 6, and it goes over here. That's V for vertical. 6 feet. So what does it tell us? 1.5 times 6. It tells us to multiply the slope ratio times the vertical distance to get the horizontal distance. That's the question mark. So let's take the vertical distance. Of 6 multiplied times 1.5. 1.5 times 6 equals, there's 9. And there's that 9 again. When we're dealing with 1.5 and 6s, we're going to end up with some 9s. So that equals 9. Now, let's keep going. Repetition strengthens and confirms. Here's a scratch pad in case we need it. Where I wrote down one of the harder problems here that we will get to. Alright, looks like we're still working with a slope, so let's draw us a circle. Let's put in our X's and O's. It's a killer when you make a mistake, time-wise. Divided by, and a little multiplier. So what do we know? The horizontal distance you intend to use on a 1.5 for 1 slope. Okay, we got 1.5 to 1, back to 1.5. The vertical distance, it says the horizontal distance you intend to use on a 1.5 to 1 slope is 4.5, so it gives us the horizontal. What is the vertical? Well, let's look up here. Here's the question mark. We don't know what the vertical is, so it tells us to take this horizontal of 4.5. There it is, the given, divided by 1.5 to get the vertical. That's going to be 3. .0 feet. Okay, let's do another one. And then horizontal goes up here, slope up, slope goes down here, vertical over here. Horizontal, vertical, and slope. This is the way it goes on all slopes. So let's see what we have. If the horizontal distance used on a 2-to-1 slope is 8, we can probably do this in our head real quick. 8 feet, then the vertical dimension is what? What slope is it? 2-to-1. So 2 goes here. It's 2-to-1. So you take 8. You can't make that mistake. So always divide on this line. So we take the 8, we divide it by the 2-to-1. We don't know the vertical, but that gives us 8 divided by 2 equals 4 feet. Here we go. One more, maybe several more. And then this line with the multiplier. Nothing goes up here. Horizontal, slope, vertical. Okay, let's see. Determine the horizontal distance. This is what we're looking for. Already know. For a 1.5 to 1, so 1.5. Goes down here, slope that has a vertical dimension of 4 feet. So the vertical is 4 feet. So determine the horizontal. So we don't know the horizontal, we know the vertical is 4. We know it's a 1.5 to 1. So it tells us to multiply the slope ratio times the vertical. Slope ratio 1.5 times the vertical of 4. That's 6. Kind of going around in circles here. So we're supposed to determine the horizontal distance, and we did it right there. One more. Keep going. Horizontal, slope, vertical. If the horizontal distance used on a 1.5 to 1 slope, we know the slope, 1.5, is 3 feet. The horizontal distance is 3, that's given. Then the vertical dimension is what? Well, that's the question mark. 3 divided by 1.5. Divided by 1.5 equals 2. So that equals 2. Let's do another one. We're having fun now. We're getting ready to change. Still in slopes for now though. All right, horizontal, slope, vertical. A 3/4, that's a curveball. A 3/4 to 1 slope has a horizontal distance of, so if we're dealing with 3/4, we're dealing with 0.75. You have to convert to 0.75. Can you see that? A shadow. Great. I got a shadow. That's not what we need. Is the shadow coming from the elbow? Or is it coming from the overhead? Let's see. There's elbows. plier. Let's try that. See if that don't help us out. Yeah, maybe this will be better. Okay. So did we get it? No. Okay. We got a 3/4 to 1, so that's 0.75 to 1. Slope has a horizontal distance of 12 feet and a vertical dimension of what? Well, again, we don't know the vertical. So it tells us to take the horizontal distance of 12 and divide it by 0.75. Don't question it. Let's just do it. 12 divided by 0.75 equals 16. 16 feet. That's what it's saying. Oh no, it's not saying 16 feet. Is it? Now I got a light issue. Let's see. It has a horizontal distance of 12 and a vertical dimension of what? Well, it says to divide, tells us to divide the horizontal divided by the slope ratio. Let's do it one more time. 12 divided by 0.75. I keep coming up with, I think it's 16 for a vertical. What would that look like? What is 0.75 times 16? 16 equals, no, it must be different. A 3/4 to 1. I got 0.75. Has a horizontal distance of 12. We got that. And a vertical dimension of, we're saying, what is, what if it was 1.6? I can't tell, there's a glare on this thing. Let me do it one more time. I'm going to do it with this other calculator, if I can find it. Guys and gals, it is 16. Now I gotta verify that. What would that look like? If I took give me a second here. That's it. It's 12. That's a really tall right triangle for a slope. That thing would look like or really skin horizontal distance of 16 and 12. Something like that. This would be 12. And this this would be 16. What is that? Curious now about something. Okay, so it works out. 12 divided by 0.75 is 16 feet. So that's the answer to that one. Sorry for the hiccup, but I just want to make sure. Let's see, 13. Oh, here we go. Look at this. This tells us we're going to percent grade. So, let's take a look over here at the percent grade. Look at it. I told you it was the invert of this. Well, there you have it. See, the horizontals over here, where in slope the vertical is there. The horizontal is up here, where in percent grade the vertical is up there. So instead of the slope, we're working percent grade. So it's going to go over there. So we'll keep this close by, but we got to continue on, and I'll show you what this thing's going to look like. This circle, because we're doing. So we'll know it says a surface street has a 1% rise in elevation from station 2100. What is the change in elevation? So what's missing here? A surface street has a 1% rise in elevation from station 2100. Oh, that's 2100 feet. So this is the horizontal. What is the change if it's got a 1%? Let me finish making this circle, and we'll jump into this one. This circle, I'm going to make it a little bit bigger since I have room, and we're doing something new. We're going to do the same thing. Almost. We're just going to change some slots around. So now the vertical goes up here. Vertical goes up there. The horizontal goes here, and instead of the slope, it's percent grade we're looking for. So usually vertical is going to be smaller than horizontal, so you're going to get a decimal, I'm thinking. So let's look at it. 1% rise in elevation from station 21. We got 2100 feet here. I'm going to write it right out here. Now, a 1% is 0.01, and it's given. So 0.01 goes right here. So what does this tell us? You can't deal with you can't deal with 1% in this form. I mean, you can on some calculators. But what we do is, in our minds, divide it by 100, and we have a decimal we can deal with. In this case, it's 0.01. So what is 0.01? If we want the vertical, we got to take, I got too many calculators now. I got to take 0.01, and I got to multiply it times 2100 equals 21. You got a vertical of 21 feet. Just what it says. We got to multiply the percentage times the horizontal, and that's going to go on and go on. So we have a vertical of 21 feet. So this thing is, that's a long ways too. This thing's going to be like this. All right. That's number 13. Okay. Now we're still dealing in percents. So it's going to ask us for the elevation change again, similar to the last one. Okay, now remember the change. Vertical's up here. Now, horizontal's down here now, and your percent is over here. So we got 4%. Divide that by 100, you get 0.04. What is it asking for? 4% over a distance of 100 feet. Most of the time you're going to multiply you're going to multiply the percent in decimal form times the length, or horizontal, in most cases. This is not 100, it's 300. So we take 300. Now, what are we looking for? What is the result in change in elevation of how many feet? That's what it's asking. It's got 300 feet. We got 4%. 0.04 times 300. Feet. We got a vertical change of 12. 0.04 times 300 feet. Horizontal distance of 300. Tells us here to take that. And if you look at these things, just remember the formula. The formula for percent is vertical divided by horizontal. The slope is horizontal divided by vertical. So most of ours are ended up down here where we multiply. Most of the time when you have a given percent over a given percent rise or fall over so many feet, you'll multiply that percent times those horizontal feet in just about all cases. So we got number 15 here. We've got a 3% grade. Now here's where we really get into some. I want to go through these. I know this is tedious, time consuming, but if you get this in your mind, you're good to go forever. I promise. Vertical, because we're in percent grade again. Vertical on top. Horizontal on that quadrant. Switching sides. So we have we don't know the horizontal, but you know what a station number is. That's the same thing as 12,340. Just treat that like 1, 2, 3, 4, 7, 5. That's station number. And that's just survey speak. To dissect these, you get in trouble. So take the larger one, which is this one right here. 1, 2, 3, 5, 6, 5, minus 1, 2, 3, 4, 7, 5 equals 90 feet. So this right here minus this, that's the distance between these two stations, is 12, 3, 4, 6, 5 would be 0. 0, 9, 0, 0, 0, 90 feet. Be 90 feet. You better stick to the calculator. We can do it one more time. 1, 2, 3, 5, 6, 5 minus 1, 2, 3, 4, 7, 5 equals 90 feet. Same thing. So we got now we have a horizontal of 90 feet. All right. We have that. What else do we have? We got a 3% grade, so we got to go over here to percent and put 0.03, because that's the way we're going to have to deal. To get this vertical, we're going to have to multiply 0.03 times 90. (27). Vertical is 27 feet. Makes sense. Okay? That's for number 15. Now, this one right here has fooled many people. This question's been around, but let's just work our way through it. Don't change anything. Actually, this is the answer. I wanted to write it down since it's a little bit complicated. I cheated, calculated this out before to make sure. So, let's use our circle. There's a few things we got to do. We got to find some things. Vertical goes up here. We got to put in our little multiplier down here. Now, 3% goes over here. 0.03. Okay. Now, read it again. A pipe station from 18980 station number has an inlet flow line elevation of 1004.00. So let's get the horizontal distance. And how do we know that? Can you guess? To get the horizontal distance, we're going to have to get the distance from this station. This is the inlet flow line. 189.80, 190, 197. So let's take the 191.97, 191.97 minus the 189.80, 189.80, that gives us 217 feet. So 19197 minus 189. These are station numbers. 189.80 equals 217 feet. So that's the distance between these two stations, and that's going to be our flow line. But it wants the that's the horizontal. So the horizontal is 217. Now, what is the elevation at the inlet? Has an inlet flow line elevation of 1004. So the elevation we know is 1004.0. Now, let's see what we can fill out. We got the horizontal, but our thing we really need to know is this vertical. So let's do what we can do. We know the horizontal is 217, so it's 0.03 times 217. That gives the horizontal. That gives the vertical. See, we don't know the vertical, but we know how to find it. We know that's going to be what we've got to have to deal with this. So if the slope is 3%, what is the outlet flow line elevation? In other words, where it comes out, what is the elevation? So we've got to get the difference in this elevation and another elevation. So we got to find that other elevation, and we're going to use it by finding the horizontal first, and we found it to be 217, and we know that if the slope is 3%, what is the outlet flow line elevation? At 9197. Okay, let's go ahead. This is the answer we need to get. So 0.03 times 217. 0.03 times 217 feet, 217, equals 6.51. So this is the difference. 0.03 times 217 equals 6.51 feet. This is the difference in the outlet and inlet, because it's the fall. I took the horizontal, multiplied it times this 3, so it gave me a vertical. And we're going to take this vertical of 6.51, and we're going to subtract it from this inlet flow line elevation of 1004 given to us to get the elevation. What is the outlet flow elevation? It gave us the inlet, now we're looking at the outlet. So we got to subtract the inlet flow elevation minus this vertical we got by multiplying the percent grade, 0.03, times 217 minus 6.51. So let me do that on a calculator. So we got 1004 minus 6.51 equals 997.44. That's pretty darn close on the calculator. 997.5. No, 997.49. We can round off to 997. Well, we don't have to. There it is, 49. We can round it off to 5. So that's the elevation at the outlet flow line. So what is the outlet flow line elevation? Well, it's the inlet flow line elevation minus the vertical distance we found, that up here, multiplying 0.03 times 2.7, this 6.51, that gave us the difference between this elevation and a 3% fall over 217 feet gave us this difference. So if we subtract this vertical dimension, which is, let's stick it up here. If we subtract that vertical dimension, it will give us the outlet flow line elevation. So see, inlet and outlet. Now, I don't know, I think I'm going to do one more of those kind. As you can see, there's that's 18, I think, is all I did for practice. Okay, so let's do the 2% fall, and then we'll shut it down. And now listen, I'm going to try to have a let's see, after each week, I think I'm going to try to have a Big Blue Button. That's a conference through Canvas, and this kind of stuff, after each week, we're going to have it on a Saturday morning, I think, at 10. I'm hoping that'll work for everybody, because these kinds of things can be talked about, going over, and make sure we're at, because you're going to see a lot of these same questions on a quiz. Let's do this one more. Uh-oh, getting bad on the circles. Probably time to get close to shutting her down. That was more like a marshmallow. Okay, remember vertical, horizontal, percent. So what do we got here? Well, we got 2%. That's 0.02. That's our percent grade. And a distance of 99 feet is easy peasy. So the horizontal is 99. So we take 0.02 times 99, and that gives you a change in elevation of 1.98 feet. 1.98 feet. Okay, I'm going to shut this down. I'm going to turn it into a video. I'm going to try to get it posted tomorrow. And then we'll talk more at some time about the Big Blue Button conference call. So let me stop the